Hey, in this tutorial we will talk about the Qt6 cross-compilation for Raspberry Pi. We will specifically cross-compile Qt6.3 for the Raspberry Pi 4. So actually I want to talk about for a much more industrial usage for this, but yeah, after the Qt5 there are some kind of big differences in the Qt6 like Cmake. So I want to specifically create a system, cross-compilation system, with the environment for Raspberry Pi with the Cmake, so you can understand how you can use it. This is not an industrial, this is not for the industrial usage, of course, but you can use it. You can embed the binaries to your application. It's up to you. So what we will do first, we will make it Raspberry Pi ready for the installation, because we need a sysroot. Right, we need some kind of libraries, dependencies for the Ubuntu. Also, we will create a virtual machine, Ubuntu virtual machine. Then on this virtual machine, then we will create an Qt6.3 host for the host. I mean, because it's not like the before. In the before, if you check my previous videos, we install Qt5 default package on the Raspberry Pi. Because this is the way. It was the way actually. So now for the Qt6, we don't need Qt5 default package in the target. We will build everything in the host environment first for the base. So be careful, we are building the base, only the base package. Okay, what is base package? In this tutorial also you will understand how this package management will work in the Qt. So first, if you want to run the Qt in the host or in the target or in cross-compilation way or another way, you need first base package. Then you should build your another packages, for example, for the QML, for declarative, for other packages, for WebSocket packages, you should build later. First you need Qt base, and you need the other packages later, according to their needs, their dependencies. Why I'm doing this? Because for faster, and I don't want to build all the Qt just at once, because it will be more error prone. So it is there are a lot of steps because of the Cmake, and I see some problems also. This is quite new. So all steps are available also in the GitHub account, in the GitHub page that you can find below in the video, in the link area. Then yeah, I will update also the page later. You can check it. Just what I will explain to how we can cross-compile, how we can make the cross-compilation. Let me explain again. Let me make summary. First, we will create a Raspberry Pi. We will make it ready, the Raspberry Pi. Then we will create the virtual machine, Ubuntu virtual machine. These are the latest versions, 22, I think. Then we will make it Ubuntu ready for the cross-compilation. We will get the sysroot, and we will get the cross-compilation, the tool chains. We need a tool chain for everything, for the beginning. Then we will build the Qt6 for host on the Ubuntu in the virtual machine. Then we will create the cross-compilation directory. Then we will create and we will just compile crossly the Qt6 base. Okay, then just boot your Raspberry Pi. With the which tool you like. I used the Win32 disk imager for my lifetime. Then yeah, just boot up to Raspberry Pi. Just click next, and choose your location. Give some name to your Raspberry Pi. I give the same name with my host machine, but you can give whatever you want. Then you will also, it is a good idea to update it. Then you will have a Raspberry Pi desktop, right? After booting, of course. So let's then first install the dependencies to make it ready, the Raspberry Pi. As I told you, all the commands are available, all the steps are available. So first we will just update the Raspberry Pi. It is already updated, I updated already. There is also the full upgrade command. So there is no, I'm just checking everything is all right. Nothing to update. Let me clear the screen with Ctrl L. Then I will update the kernel. Why I'm doing this with the RPA update command? Why I'm doing this? Because I will need some packages, some dependencies in the next, not for this specifically for this tutorial, but I will show you after the Qt base, not in this tutorial, not in this video. I will show you how you can cross-compile the modules also, you know, as I told you before, the Qt declarative, for example, Qt WebSocket package, other packages. So this is, as you say, this update the kernel, okay? This is not not exactly a good idea. If you don't do this, you will have the compilation success, end of your steps. But in the next, for the OpenGL, for example, for embedded systems, for OpenGL ES, for example, we need some libagl SO dependencies, shared files. Then if you need this, then you have to update. This is one of the way you have to update the kernel that you will have the packages, all the things. So I click the yes. After this, we will have a firmware version. You can update to this version if you want, because there can be some differences about the packages. So I'm updating some kind of, some specific tag, specific commit, the latest commit. But in the next, for 1 year later, for example, I don't know, there can be problems. So it's so depends to dependencies, depends to, I don't know, this repository for the RPI repository, let's say. So it's a good idea to RPI update and put that I will show you now, the commit number, okay, that you can find on the GitHub page. But it's up to you. You can try first, so it's not a big deal. You will see at the end, during the configuration, you will see the error. If you see the error, then you can do it again. It's not a big deal, but you have to, of course, update the sysroot again from scratch. It will take just a few minutes. Updating the firmware. So why we are doing the cross compilation here? Because it's fast, right? I told you before. This is not the only way. You can build directly the Qt6 on the Raspberry Pi. But this will take time. This will take maybe days. I don't know. I just tried to build a Qt base package on the Raspberry Pi. It took around more than, I think, the 4 hours or something. I have 4 GB RAM on the Raspberry Pi. This is not nice. So I need to be quick. I need to be fast. That's why we want to use a cross compilation. But this is quite hard for to maintain and because of the dependencies. So the update is finished. It will, the Raspberry Pi wants you to reboot the system. So let's reboot it. After this, under the boot directory, we will see a number, the commit number. Okay. So in the next, for example, if you want to deploy your binaries for Qt binaries to new Raspberry Pi, it's a good idea to use this commit number. Otherwise, there can be different version of dependencies that you have to build everything again. So you don't have to do that, right? So if you want to have a new Raspberry Pi and you want to run the Qt binaries in this Raspberry Pi again in the next that you will build now, so just RPI update your Raspberry Pi with RPI update and use the commit number that I will show you. So it's a more safer way. Otherwise, that after 6 months later, there can be some package dependencies. The version can change. One package can break everything. So your binary, your application will not work. So what I am doing simply, so if you check boot firmware version here, so you see here a commit number. This is a commit number. So just save it somewhere. Then you don't have to use, I think if you use something like this, it will be okay also. But for example, you have another Raspberry Pi, okay, and you want to update it to use your binaries, Qt binaries for your application. So you don't have to write, you shouldn't write actually like this, just this, and this will update to the latest version, but you don't need the latest version, right? So because we will bind here, so you should do this for the new Raspberry Pi, okay? Then you will see no problem. For example, after 1 year later, if you update it without the commit number, probably one package the version of the one package will be changed. But you bind this package, this current version for your Raspberry Pi, for your Qt binaries. So Qt binaries will not work on the latest Raspberry Pi as it's expected. So use this commit number, that is it, if you want to use this binaries again. Now we will install dependencies, the packages like for OpenGL, for some X11 dependencies, Xserver dependencies. So all the packages you can find in my GitHub environment, so in the GitHub link. So don't worry, I will just paste them. So these are the dependencies, and Boost, some kind of Mesa dependencies, so development packages mostly, and the binaries time to time. So let's install them. This is the first, actually there are others also that I will show you. This will take some time. So this one finished. Let me clear the screen. And there are other ones. So these are the other packages. Just copy paste from the page. But yeah, some of them are not necessary for now. But in the next tutorials, in the next video contents, we will need these things. Okay, that is why I just want to install it. Some of them I already installed because of the dependency issues in the dependency of the first, packages that we installed. This will also take some time, so don't worry. This package is also installed, so I want to delete 3 packages actually. One of them the dev packages, and the other ones the binary ones, the binary packages. I removed this. Actually, these are the workaround. I didn't check. I saw some problems with Cmake with these. So because of these packages, the cross compilation was failed. So I just want to remove them. These are not a big issue, but I will check it and I will let you know later. So these are the packages that we want to remove. Yeah, installed already. So if you have installed these things, just remove them. Okay. In my case, it's not installed, but if you have them, just remove them. Then let's create the directory that you can put the binaries wherever you want, but I will put under the local directory in the Raspberry Pi. So I want to create a directory for this, okay? Because I will not use any super user, privileges in the Ubuntu also. That is why I want to do it now. So otherwise it will give some issues. I saw before in my old video, people had kind of problems with the sudo permissions. So I will not use any super user privileges in this tutorial. So I will give the Qt6 RPI. Yeah, I made a mistake here. This should be USR. So yeah, if you check the ownership of this directory, then yeah, this is for root, but I will not run any super user. Then let's give the our user for the responsibility for this directory, which can be done with the change ownership. So I will write here my name, the username here, but you should put yourself, right? Your name. You should update here according to your username. So just USR local Qt6 RPI. Let's try again. Ta-da! Okay. So now the ownership for this directory is my username. It's okay, my user. So that's it for the Raspberry Pi preparation. We will come back here again. Okay. So let's keep it Raspberry Pi. Let's keep Raspberry Pi run in somewhere. So please, be sure it's connected to the internet, and you should be able to ping it. You should be able to connect from the SSH also. Well, but we didn't enable the SSH, right? So let's do it, because we didn't enable the SSH. I forget it. So if you type sudo raspi config like this, so there is an interface options here, SSH. So it will ask you, would you like the SSH server to be enabled? Yeah, we will say the yes. And the SSH server is enabled. That means we can access it from our virtual machine or somewhere, Then it's finished. Don't touch anything more. We have, you should see the IP address here. Then this is my IP address. Then I will use this IP address to send the directories, the packages, and I will get the sysroot, from the Raspberry Pi to the host machine using this IP address. So be careful about this IP address, otherwise we cannot cross-compile in the virtual machine. So the next step will be about the virtual machine. Yeah, this is the Ubuntu virtual machine. For the virtual machine, I will use the this what was the name of the VirtualBox manager to create the virtual machine, Ubuntu virtual machine, the Linux virtual machine. So it is easy. I did it before, so I just wanna show the steps again. But if you know this how to do it, just skip this step. But it's not a big deal. So you just click the new, give some name, and I will give Qt6 rasp. Let's say this is the name of the virtual machine. It's not a big deal. So here I will choose Linux, and this should be the Ubuntu. 64-bit is okay. It's okay. We can choose 64-bit. Then click next. But here, of course, I will choose the location. So I will choose here. I created a directory for this, and I will choose this directory path. Okay, you can choose wherever you want. Select next. So this is this is the memory size for the the RAM amount of memory. I will give 8, but if you have more, it will be better if you give more. So the hard disk, create a virtual disk. This is now the don't edit one. This one is okay. To create a virtual hard disk now. So it will ask you to the VDI file, virtual disk image file that we installed. You should install from the internet, from the Ubuntu default Ubuntu website, let's say. So dynamically allocated it should be. Then I give here 150 gigabyte or more, you can give it, doesn't matter. Then it will create it for us. But where is it? Here, this one. You will see here. Then it will ask you to disk. So go to your the path where you keep your disk. I will add the new one. This one I will use Ubuntu 22.04 desktop AMD 64. So that means I am I am using the Windows now. This is the host machine, right? This is the cross compilation. This is the first step that we will compile cross. Why I'm using the virtual machine here? I don't need, actually. This is not a necessary step, right? You can use your own Linux, but every Linux has different kind of dependencies inside this, right? The different packages, so it's so hard to maintain. If you use the default, or if you use another Linux distribution, or I don't know, not virtual machine, not this version Ubuntu, then you can see maybe some problems. But I don't want to see these problems. This is why in this video I'm using this version of the Ubuntu. Okay, so please use this version. Otherwise, you can see the problems. Okay, I cannot handle this. So open it, choose. Okay, start it. So it will ask you try or install. So okay, that's install. No, cancel. Just click enter. It will go with this small screen, but we will make it bigger. And the next. Don't worry about it. As I told you, if you know how to build this, how to create a virtual machine, then just skip this, step, skip this part. Please also, use the same things here, same versions, same packages as much as possible with me here. Otherwise, you can see problems during the configuration, during the compilation. It's so hard to understand, right? It's so hard to maintain it otherwise. One package can break everything. Yeah, think like that. One single, simple package, simple development package, development dependency, some different versions can, break everything. This is the hard part of the cross compilation. Also, tool chain is important. I will explain it. So we will have now nice weird desktop. So then choose the install Ubuntu. We will not try it, right? We will install it. Yes, English, okay for me. Yeah, this is a little bit small, or I don't know. I cannot see all the buttons here. I don't know why, but it's okay, I think. Maybe because the version of the VirtualBox is old. Maybe, I don't know. I will use English language, the normal installation. Don't updates, okay, you can install it. So don't install the third-party applications. I will connect, via the cable, so I will not use a Wi-Fi for the virtual machine. Just click next, and choose your location. This is erase disk, install Ubuntu. Okay, don't worry, it will not install. Installed array is your real disk. This is the virtual disk. So yeah, choose your location and give your name for your VM. I will give the name the same with the Raspberry Pi. I will delete this password. I will give the 1324. It's so secure. I'll log in automatically. Continue. This will take some time. Yes, and we can start to prepare the Ubuntu. Installation is finished. So yeah, it wants you to restart the virtual machine. Just restart now. Click here. So it's asking please remove the installation medium. Yeah, there's no medium in virtual, so just click the enter. Otherwise, it will wait here. The version 6.1 I'm using for the VirtualBox. Probably it can be different, for you. Yeah, after this it will start. So that you can skip this online account part. Just remove it. Next, okay. Actually, I don't want to send. No, I don't want to send system info. So location is okay. This one done. So now, yeah, we have virtual machine, but we have a problem with the screen here. See, this is not a good idea to work like this. So let's first fix this screen issue, the screen size. Then we can continue. So we should insert here the guest editions from the device. Choose here, insert guest editions CD image. So you will see here. Click here. The CD. Then there are some scripts. Just let's make it from this terminal. Open a new terminal here, and autorun sh. Just bash autorun sh. Then it will ask you the sudo password. Just 1 2 3 4 mine. So this will fail because there are some packages that we have to install. I just want to show you. So yeah, as you see, it says here, please install GCC make Perl packages. So copy this, copy, enter, then sudo apt install, paste here the required packages, install them, enter your password, yes. Probably it will ask you again to reboot, but let's see. Okay, we are here again. Now run auto run sh again. So it will ask, yeah, same password. This time it should work. Otherwise there is another problem. Let's check. If you don't have this VirtualBox, this guest editions, then you can search on the internet according to the version. You can find some steps, how to install it. So now went wrong. VirtualBox guest editions running kernel modules will not be replaced until the system is restarted. So okay, it wants us to restart the Ubuntu. So simply sudo reboot. Okay, it reboot again. If you extend it here, as you see, yeah, I saw this issue before. So now actually we solved the screen problem, but there's still some kind of an issue here. I don't know why. So if you go to logout, just for workaround, if you go logout, this will be fixed. As you see, we can extend the sizes now. Why it's here. So open a new terminal. You can right click on to the desktop here, open terminal, or you can just, the shortcut Control Alt and T, then you will have the terminal. I just make it a little bit bigger for you. You can see easily. So I will continue all the steps in this terminal, right? We are starting to, preparation for the environment, for the virtual environment now, and we will compile the Qt, crossly. So don't close this terminal. I will do everything in single terminal. This will be more easy. Before that, I forget to mention something. Just for a quickly we can, power off the virtual machine. I forget to enable some features for you. It will make it will make it easier for installation. In the VirtualBox, go to settings, choose your VM, of course. In the advanced, you can copy something from the page, another page. So enable these things. It will make you able to copy and paste something from the virtual machine to your computer, or vice versa. Choose bidirectional. Your bidirectional here. And description. These are okay. So then the storage is okay. System. This is 8 GB for me. The processor, you can easily increase the number of the processor here according to your host machine, the Windows machine. So don't touch here execution cap. This will be 100%. It's okay. If you don't increase this, then the compilation will be slow, right? So increase this. The acceleration is okay. So click OK now. Then run Raspberry Pi virtual machine box, Ubuntu virtual machine box again. Okay, open the new terminal after the reboot. So we can check, for example, which version we are using, like this. Yeah, this is the Ubuntu 22.04. So be careful about it. They should be same, otherwise, I don't know, some packages can be different. As much as possible, all things should be same according to here. So first we should update. Let's get the update the system and the upgrade. Upgrade. Update is finished, so I clean the screen here. Now we will install some development dependencies, development packages for the host. So I just copy from the page that from the GitHub that you can find. So install all 600 megabyte. Say yes. Probably it will take some quite time. After installation for this dependencies, then this is the step. The next step is for the Cmake. So I don't have a Cmake, I think now. Yes, I don't want to install, you know, using the normal package managers, because this related the current version I checked, there are some problems about for the Qt6, I think, because it couldn't find some packages. I don't know why during the cross compilation I saw. So that is why I want to use the latest version. So what we will do now, we will simply build from the source. Before building this, we need a simple SSL package. This one. Just install this SSL dev. I didn't try without this, but you can try. First, we should clone the Cmake repository. So I'm in the home directory. I will do everything in the home directory here. After cloning, so then enter the directory. The installation, it's actually the building is so quite actually easy. So just run the bootstrap and make, then sudo make install. This will install, you know, to the default directory that we can use the Cmake. Yeah, after make, for the installation, it will ask you, you know, to enter your password. After this, you will have the Cmake. Just enter your password. So this is a building and installing. Yep. Now when you type version, then yes, I have this 3.23, something like this. Then yeah, that's okay. We install the Cmake, build the Cmake successfully. Then we should, now the next step, that we will build the Qt host, Qt6 host. The next step, we will build the Qt6 for the host environment, because this is the new way. If you want to compile crossly, you know, if you want a cross compilation, before I told you before this, for the Qt5, you have to install the target, and for example, in the target you have to install the Qt5 default, right, for the headers. But now this is not necessary. The headers you need on the host. So for the base that we are compiling the base here, now we will install the Qt base. First we will build for the host, then for the Ubuntu, then we will cross compile it. Okay, then go to home directory that I told you, everything I will create here for the directories. Also Cmake is here, but you can do it in another, you know, in another path. It's up to you. You know, maybe there can be problems with the permissions, but you can handle them. So then I create another directory. The name is a Qt host example, or let's not example, build. Let's say build for this Qt host build. Qt, let's make it more better. Qt6 host build, like in steps, and enter it. So now we'll actually not here, right? Okay, before this, let's go back, then we can install it here. So we should install the Qt base now. Let me explain first what is the Qt base. So before, and if you watch my previous videos, so this is the official releases of the Qt, okay, the website that we will use to install the packages, okay, the Qt packages. So if you click the Qt6.3, this is the directory. So there are some other diffs here. So there's a single directory and a submodules directory, okay. In the single directory, there is then the whole Qt that you can build it. This is all the packages, all the modules inside this. Okay. So which modules? The modules, the submodules here. So these are all the modules that is in the Qt base. Okay, the single, I mean. So why I'm not building is a single one. This is more easy, but it's more error prone and it's more longer because it will try to build everything. Okay, I don't need some of them, right? I don't need maybe this one. I don't need maybe this one. I don't know, right? I don't need it. What I will need, the first one, the first you have to do, you have to build the Qt base, which is this one, the source Qt base everywhere source. So after this, you can build the other modules. All modules depends this. Okay, this is the first step. You should do it. It doesn't matter in the host or in the target and in the cross or for the cross compilation. It doesn't matter. Okay. So then we will check how we can build the modules in the other tutorial. But specifically in this tutorial, in this video content, I will focus to build the Qt base. This is the idea. So let's copy this. Copy the address of this link. Okay. Then come here. Then with the get command, install here. Qt base source 6.3.0 tar xz whatever. Then we will extract this in the directory for the Qt6 host. So now we will build the Qt, as I told you, we will build the Qt6 for the host first before the cross compilation. Let me clear the screen again. And I will create a directory for this, and then make it more, abstract everything. Qt6 host build. You can give whatever you want. You have to pass this path to the Cmake in the next for the cross compilation. So go inside this. Let's enter here what we have. xf. It is something like this. Yes. So with this command xf and go to the above directory and choose your tar file that we installed before. In the next version can be different. I just try to build the latest one, but I'm sure that 6 months later maybe you cannot find this version. So try to the best one, the last one, and do the same steps. So enter here. This will take quite not long time, but yeah, it will take some. Yeah, it's finished. So now we have a directory here, Qt base directory. What is inside this? In this directory, there is the Cmake, bin directory, some headers, sort of base for everything here for base, Qt base. Okay, not for the other modules, submodules. So what you can do with the Qt base that I will explain later. There's a network package inside. There's a Qt widget package inside that you can create some simple GUI, reading some pictures or some simple, not HTML applications, some network applications you can create. I don't know. Now, okay, here I'm just copying the command for the Cmake. Paste here. So this is a Cmake command. As you see, we are not using configure. Before for the Qt 5, we were using the configure script to make the configuration. Now we don't need it because we have a Cmake. So you can do it still also, but in the next, it's not. They will remove probably. So what is this? This needs the Cmake for the build. So this is the which type of build you have to you want to make. Actually, it's the release and the deb info. This will provide more debug info, I hope. And this is the OpenGL is enabled for me. It's not important really, just they will look for the headers, I think, but I did like this. So the build examples, I make it off because this will take some time also. So test off for the time. And this is the installation prefix. This is important. So we will see after installation the Qt6 for host here. Okay. I didn't create this directory. I hope there will be no problem. Let's check. So I run the Cmake now. There is a warning because I didn't provide any source directory. They say it's a problem in the next, but it's okay now. So don't worry about it. Maybe you will not see this. Now this is a configuration, not building, for the host, Qt6 host. Also, you can suppress this warning with this flag, but it's okay. This is okay. you should see at the end the configuration is done. Yeah, then you can build now. Otherwise, you have to check. Let's check. Yeah, this configuration done, generation done, build files have been written to whatever here. So what we have now? If you check here, there is a config summary. Normally in the Qt 5, and also I saw this in the Qt6, the older versions, the configuration also printed here, but it's not printing now. I don't know why. I didn't check. So we can check with the cat command, for example, the config summary. It wasn't there before, right? The config summary file. So now here, as you see, you can check your summary of the configuration. For example, yeah, we have dbus, you know, all of them. Yes, XML, widgets, and other things. I don't know. Let's check the OpenGL. Yes, it's enabled because it's enabled. Yeah, this is enabled. As you see here, we enabled it. For the X11, these are AGL on X11 is enabled. It's okay. There is no problem much. So we can continue. What we will do now, we will build it. Let me clear the screen again. Cmake build dot, and I will give the parallel, you know, the number of the core, so that it can be more faster for building. But I made a mistake. Cmake build parallel. Yeah, I forget the lines. Sorry. Here, dash dash. Then this will build. This is the number of the packages, number of the objects file that have to be binded, you know. So yeah, this will take some time. Also, this is not nice thing, not a nice or bad, but now the default Qt version is not a 6 for the Ubuntu, right? So for the exact version, also this can create a problem for you. For example, if you wanna cross-compile Qt6.3, you need Qt6.3 in the host also. But if you want, for example, you have in the host Qt6.2 something else, then this can problem for the Qt6.3. I mean, I'm trying to say that versions should match. This is a quite maybe, you know, it will take some time to build all. Before, what we were doing, just install the Qt5 default in the target, and you know, just take everything to the sys root. So everything was quite, you know, nice, actually at least easy. But now this is the step. So yeah, you can wait or get a cup of coffee. You don't have to do anything. If there's a problem now, then I will show you. Otherwise, we will continue. So the linking is finished here. As you see, the number of the you know, the objects are. Yeah, this can be different for you, but this, when it's all completed, that means finished. So now we will install it using the Cmake install and that. This will install that we before you know, we gave the path Qt6 host. So this create a file directory for us. After this, yeah, we install this. Then yeah, let's try some example, you know, in the host, so we can understand what is it, because it's the same way, the same way that we will compile for the application. It can be used for the also the cross compilation. So if you go back and back more, you will see Qt. So here is you see Qt6 host. Okay, so if you go there, there are directories. Bind documents include the header files, library, whatever. This is all for the Qt6.3 base. Okay, for a host. We haven't done yet anything about a cross compilation. Then okay, let's create. Actually, here I just want to show this. There's in the bin file, there are some scripts. Okay, Qt6Make, Qt configure module. This one is used to compile your binary, to configure actually your binary. Then you like a Qmake. Okay, let me show you. Let's go back one more and create some Qt6. Let's check the Qt host example. Let's check Qt host example. Go there. So I provide this, just copy here. This will create a main CPP and just print hello world. That is it, you know. And it will call this libraries, core application and debug. So we need a Cmake list now. We don't need a Qmake anymore, right? Before we had pro file for the Qt5 applications, right? .pro, project file, whatever. Now we don't need it. We need Cmake lists, txt. So I also provide this in the page that you can find, that I'm just copying here. So this is a Cmake list. Okay, let me show. So this is the this is Cmake now. So I just put here minimum required version 3.5. Yeah, you can change it. Which one we were using? I forget it. 3.6. Then this will fail, right or not? I don't know. Minimum required. That's right. Just because it's wrong. Then yeah, this is the language and this is the project name. This will be the binary name Qt6, Qt6. And these are normal flags. Then here the standard variables for the Cmake. These are standard variables. So this will looking for the package. This find package. This is Qt6 core. So we just build it right for the base. Base includes Qt6 core. And finally we bind the main CPP to our binary, and then we link the libraries Qt core to our binary. So let's try for this. Then what we will do, we will call this Qt6Make, direct Qt6Make as script. Then just go this path Qt6 host bin Qt6Make. That should be, yes, this one, and run it. That is okay. There's no problem. And yeah, you don't see any problem. Oh, nice. Okay, now let me clear screen again. So Cmake, we will build now our host example, and it's building. There's a problem. So we can here, as you see, the binary. We can check with the file command. It is for, as you see, that this is for x86. That means it's an Intel here, the architecture. So we can run it simply. Hello world. So Qt6 compiled here, you know, successfully. So we can run in the host environment. This is good because we need it for the cross compilation. So this was just an example for just a simple one, hello world. So now go back. Then what we'll do now, and yeah, this is the toolchain step. Yeah, we should install the toolchain. You can create your toolchain, or you can use one that you can find on the internet. But it can create some problems. Okay, so I can update this pet toolchain again in the next. Maybe you can check it. But now it's working. I tried. So the toolchain directory, it should be in the opt directory. It must be actually. Yeah, this is because of the toolchain stuff. So just go to opt. Actually, before we should create the directory for this name RPI. It should be like this. You have to do the same thing with me here. Yeah, because of permission denied. Yes. Then with sudo we can do it. And let me go there. opt RPI. Then we will get a toolchain from this link that you can find. And the page again. Okay, this is just a tar file, which includes the toolchain, related toolchains for the cross compilation. You know, you need a toolchain, right, for everything. It doesn't matter. When you wanna build something, when you wanna create a build application, the first thing is the toolchain. So here the tar file, downloaded here. So you can check it. So it's just simply, you know, with the tar, xf rpc. Yes, because of the sudo we need. No, it didn't work. Sudo tar, let me try again. Yeah, this will take some time also. At the end you will see like this, you know, the root, and this is the plus, but I just extract it, you know, untar it. So okay, this is okay. We can. What is this inside? Let's check. If you check this inside of this, yeah, there is an as you see that for the hard float, the GCC, you know, G++, the tool chains we have. We can compile the simple application here, for example, right? So let's go the ARM. As you see, there's a we can check the bin directory here. For example, the LDD that we can you can use to check LDD version that we can. For example, let's copy this path and LDD version that we can use. We can see actually GNU libc version here. You see, yeah, this is just a tool chain. I explained this much also in my previous tutorials that you can watch also. Okay, these were also nice to learn in the beginning stuff. So let's go to the home directory again. Okay, we are home ulaş. I mean, yeah, we are our home, the user home. Let's say. So then we will create. Yeah, we can. This is this SDK, the sysroot we have to copy from the target. Now we are the Raspberry Pi is running right now with me. So let me try to ping it. 6. Yeah, I'm able to ping this. Yeah, you should see this. Otherwise, it will not work, right? You have to ping your target because we will take some package there. So and also we will send at the end the binaries. Then. We will create some RPI SDK. The names are not important for this in the home directory, but the toolchain is important. Okay, toolchain for the toolchain, you have to do exactly what I did here. You have to do exactly the same. Create a directory. Go inside. RPI SDK, and we will create here 3 directories: sysroot, USR, sysroot, OPT. Then with the rsync command, we will sync the files, the directories, and the target to here. So we will copy what we have for the dependencies, development packages, everything in the sys and the USR, include file directories, copy from the target to virtual machine for cross compilation. Right? We will give this path with the toolchain in the Cmake, in the toolchain file. We will have the toolchain file for the Cmake. This is the cross compilation, how it should be done with the Cmake. So simply rsync. This is just an options. Don't worry right now. Rsync path. This is more for privilege. Sudo rsync. One person committed this comment to my repository before. This is what I'm using now. So this is the username of the Raspberry Pi now. We are just connecting now Raspberry Pi. So the IP address of the Raspberry Pi. So this is important because be careful about the slashes and the name of the directories, right? Otherwise you can see a problem. USR, like me for example. USR include. So we will get the include directory, whatever inside to here. Sysroot. Not like this, of course. Sysroot and USR. You see that I'm not typing there include, right? Because this because of compilation, that Cmake will not look there. That's the point. So we should put it inside the USR file. We can change this, but not in this tutorial. It will ask, yeah, you can say yes because the new device. I think that's why it's asking for the key. So yes, then add it permanently. It will ask you the password. So enter the password of this sudo for the Raspberry Pi now, right? So it's the same for me, but it's okay. We will do this for the lib in the target, USR lib, and the OPT VC for the further usage. Not in this, we will not use the libraries in the OPT, but further usage for not now. Maybe we can change the configuration in the next. I will show you. So I will copy the command here. I will not write again. This is for the lib, and I will copy the lib under the sysroot now. It's asking password. Yeah, there's not much thing. Then copy here. USR lib under sysroot USR. It's asking password again. So this one is finished. Let me clear screen again, and here another one, the last one for the OPT and the WC for this the OpenGL. Actually, I'm doing this for OpenGL embedded ES SO file, but we will not use this in this tutorial. But in the next we can have it. We can use it, right? So that's okay. That's done. We have to fix the relative links, because now, for example, we got these things from the the Raspberry Pi. So because of this, some relative links, some soft links can be broken now. They're all broken now actually. So we have to fix this like that. Just copy this, and this is the Python file, which will fix everything for us. I mean, using this, I don't know. So we should first change the permission for the executable. Sysroot. I hope we have a Python, by the way. I don't know. Let's try Python 3. Yes, we have. And sysroot, we can use a Python 3 sysroot, and give here the path. That is it, I think. And it will fix, as you see, the broken ones. Okay, so you don't have to worry about it. There are a lot of quite much, not much I hear, but yeah, it's nice. So let me clear screen again. Now, yeah, we can start to compile Qt6.3.0 for the Raspberry Pi. So let's go back to home directory. Let's stay like this. So we will create a Qt cross directory that you can give whatever you want, but be sure to, when you will run the Cmake, just be sure you will paste the same, you will write the same path, same directory names. Enter this again. And now we need a toolchain. That is the point. That is one of the important part, because this Cmake for the cross compilation, Cmake is working with a toolchain file. That's the point. What we are providing this toolchain file. That's simply the sysroot and the toolchains, that we installed, right, for the Raspberry Pi for cross compilation. That is, then you just flex. Of course, it's according to your system. So I write already once, just then I'm copying it. So this will create just the cat with the cat. This will create a toolchain Cmake. The name is not important. You can give whatever you want, but then you should pass this at the end, the Cmake. So give the same name, not right now, like me. So there are still, the minimum, whatever, the global include guard. So as you see that Cmake system processor is ARM, because Raspberry Pi is ARM, right? So it is Linux. So as you see, it is target sysroot. Target sysroot is important. So this should be same. No, you can remove this. Yeah, sorry, this is the cross compiler that I was talking about. Yeah, this you can remove it, but this is the sysroot here, right? The target sysroot. That's why it's important. Target sysroot, it's where your all dependencies for development packages, stays here for the target, right? Just with the rsync command, we copy it here, right, to the host. That is the path. So then we will provide the cross compiler from the toolchain. This should be same exactly with you. So then these are all same, that you don't have to touch anything. This is the Cmake sysroot. I created a new one, Then this will be Cmake sysroot should be used here, somewhere here. See, compiler, cross compiler. Actually, I didn't use it, I think, but it's not important much. So you can put Cmake sysroot here. It's not a big deal. Maybe I can update it. Then these are the flags for the compilation. Okay. These can stay, as you see, they are USRlib, sysroot, USRlib, Cmake library architecture. You can print these things also. I mean, we also set here, right? ARM Linux. If you go this directory, then you will find this in the sysroot. Otherwise, it will give you an error. Then that is it, I think. But let me check with the. Yeah, this is more clear now. Why it was given like this? Interesting. So we set the flags here. This is the ARM V8, the Raspberry Pi 4 architecture, and these are the necessary again. The hard float. You can play with these things. And I add the LP threads. Yeah, I saw a problem actually. it couldn't find the thread package. I don't know why. So I add this to find the package for the threads, then it worked. So now this is the one of the last step before cross compilation that we need, and here the directory for Qt6.3, right? So that is why extract the tar file again for here, but for different directory, right? We extract it before for the Qt for the host, right? For the Ubuntu. Now we will extract this for the Raspberry Pi, for target, whatever you have. Tar xf, go back, Qt base, whatever here. I want to extract on tar here. So we will have the same directory, but they are the same, right? We compiled first one for the host. So we are not using the same one. So now we have here Qt base, and we have here toolchain. We will come here. In this directory, we have same stuff, everything. So just we will provide a different Cmake commands with the different flags with the toolchain. That is. I will copy the command. Just a second. I don't want to write again everything. So I will explain it. So simply, this is the build that I told you before. So this is the release, or you can put the release and debugging for again like before. So I enabled the AGLFS, as you see, the Qt feature. This is the flags. These are flags, and you can find on the internet also. And also AGLFS here, I enabled it. We will see in the configuration these things. So this is cross-compiling example of tests of again that I don't want to spend much time. So host path, this is the Qt6 host, right? We build it here. So it will look here for some specific headers or something else. For the staging prefix, this is the directory that we will see at the end. When we will make install, we will see our cross-compiled Qt binaries here. So this is, you don't have to write, but it's okay. We can keep this like that. We will not use it. So this is sysroot file until the lib. See the prefix path, the lib until lib. Then here the toolchain file that will provide, toolchain file just above, Qt cross and toolchain. We just create it. So this is just a path of the here, nothing more. So I will start it now. Then didn't configure. It says it's inconfigured. Okay, yeah, the problem is, because of this, I made a mistake with the cat command. We cannot copy this with the $sign. It was the problem. So I updated again toolchain. So it is the correct one. Just don't use with the cat command here. You can just copy, create, get it, and copy the content here. Content is same. I didn't change anything. They are still same. The just 2 lines that you have to change. Not 2 lines actually. This line you have to only change if you just a username, nothing more. These are same. Just go back again. So now we have to remove the Cmake cache if you want to configure again. So come here, then try again. And then the configuration is started. So with the cat command, it's not working. That was the problem. So we saw again this warnings, but you can suppress with this command. It's not a big deal now. We will compile successfully at the end. And as you see, the configuration is done, generating is done, whatever. Now clear screen again. So we will now build everything. Cmake. But before it, I forget it. So it was like the before. There is a config summary, so we can check the config summary. So it's the configuration, and here some AGLFS that we enabled this one, right? AGLFS device, as you remember. AGLFS LGL device and AGLFS GBM, they are enabled, and yes. Then OpenGL yes, desktop should be yes now, but I didn't enable these things. We can do that next. Okay, so just let's talk about just cross compilation right now. I will explain these things, the platforms, in the next contents, not now, because it's making more complex. So that's okay. Then we can Cmake build here and parallel 4. like the before. So there are more than 1,500 object file to compile. So yeah, we will wait and let's see if there's a problem or not. If there's a problem, then we have to fix it. Yeah, we will see. Okay, so if you see these, the number is matched with the right one and the left one. So congratulations, you just compiled the Qt successfully. There is no problem. If you see the issues, yeah, you can write a comment. You just leave the comment. Let's check together. But yeah, there are some warnings. As you see, there are some bunch of warnings stuff here. I didn't check, but these are okay. There is no really problem. Here, really long, so no problem. Then, what we will do? The next step. Let's check the directory, right? So, but we forget to install it. So we will install here like this, cmake install dot. So this will install the binaries, packages, whatever, to the, as you see that Qt6 that we created before, right? Actually, we gave the path, right, for the Cmake. Just remember. Then I will just go this directory to show you the same stuff. Like, as you see that it's like a host. It's the same, just for the architecture, the binaries, the way is different for the compilation, right? So as you see that in the bin, for example, there's still, let me clear screen and here, yeah, Qt6.3.0 C file that we will use to compile crossly right now. So let's create a hello world application. Like the first one here, Qt host build, or what was the, I don't remember it, host example. So now let's create another directory, Qt cross example, I don't know. So go there inside, but before it, let's send the binaries to the Raspberry Pi, right? So to do this, I just copy the link again. So I using the same rsync command. So to the that we created in the beginning, right? USR local. So we will create this. We will send this all Qt6 RPI to the local now. It is asking password. So as you see, it's sent everything. Now our cross-compiled binaries for the Qt are in the also target. Now, let's continue our cross example. Then I will create a main which will be the same again. I'm just about to copy it here. So cat main cpp just and hello world, hello world here, nothing more. That we will print this in the target right now in the Raspberry Pi, and before, of course, we will compile it. So for the Cmake list, I'm not sure it will work. Let's check. It didn't work, right? Or it worked? Oh, this didn't print it, some of them. So I will do this with the gedit right now, but I can fix it, or you can check it. I mean that these should stay there, right? These should be, all of them stay there. Now, as you see that here in the Cmake list for the this application, hello world application, there is this flag, we didn't define it here, so it's in the now Cmake for the cross development, cross compiled, right? So if you print this, you will see it probably. Yeah, but not probably, you will see it. So save this. Then using the same command, but in a different, it's in the Qt Cmake script, but it's in a different directory. Qt6 RPI, go here, bin Qt Cmake, enter this. I forget this to remove it, sorry. Let me remove this. Yeah, I just copy this. That's my mistake again. So yeah, this is the same, but the difference here, as you see, we just give the flags, right? Before in the host example, there is no flags here, so we will give the sysroot directory. That is the difference. So let's try again to run. Okay, configuration is done, and Cmake build. Yeah, parallel is a simple, you don't need to run the parallel. So okay, now that's compiled. Nice, there is no problem. So it's the ARM. If you check with the file, you know, the binary file command, so you will see it's compiled for ARM. That means we cannot run it right here. So we cannot execute binary exact format error because it is now here Intel, not ARM. So what we'll do, let's send this to the Raspberry Pi, to the home directory like this, for example. It's asking. Is it wrong password or not? Yeah, because of some reason the Raspberry Pi sometimes make me wait more. I don't know why. Maybe because of my Raspberry Pi or the operating system, but I don't know. I saw this issue before. So wait, be patient, okay? If it went, yes, just an 12 kilobyte, but it took some time. So we can go to Raspberry Pi now. So now we are in the Raspberry Pi, right? So, whoops, let me, another wrong keyboard. Let me clear screen. And as you see here, our binary is here, right? Then, yeah, if you run this right now, that it will give you error because we put the binaries under USR local. You know, we have to give the lib directory. Where's the libraries? We have to define it because, you know, it cannot find the libcore6. So if you check with the hello Kit, I'm representing this because you can debug it if you have any problem. So if you see this, it can be slow still in the first time. I don't know why, but yeah, wait, be patient. Otherwise, you should send the binaries again if you see a problem here. For the first time, it's loading something, I think. I don't know, or it's checking the system. So here, that as you see here, the Qt6 core, the so file not found. Yeah, but we send it right. Let's check. USR local Qt6 here. Lib. It's here actually. Let me. By the way, these are the base binaries, as you see. It's here, see? Why it's not working? Because we didn't export them, right? So we should export ld library local Qt6 RPI and the lib. Here, right? This SO files are laying here. Then let's try to run the Hello World application again. Hello World. So it worked. We simply compile. We actually cross-compile the binary in the Ubuntu. We cross-compile the Qt6 application with Cmake in Ubuntu host machine for target, which is Raspberry Pi 4. That's nice. So it will be fast now because the libraries probably load the cache. You know, that's okay. So now we can check some, for example, what is inside the core. You know, Qt6 core. What's inside? For example, there is a GUI parts, GUI libraries. Let's try to load some image. As a simple one. So today again, I will create here another directory. Make there Qt cross example GUI, let's say, and I will go inside this. Then I have again the cat command, but I will probably change this in the, because of the tool, the Cmake list is not working, right? I can paste with the gedit, right? So simply what I'm doing here, as you see, I create the main CPP file for the next example. So this is the path in the Raspberry Pi. Be careful, right? So this is not the path is here. I will not embed the image in the binary. So be careful is this here. So I changed the username here. Test JPEG. You can use the JPEG or PNG. They are working nice. So as you see, I have I loaded a Q application label, and I have my image, Q label, Q label, and we will show it. This will work in the Raspberry Pi now, I hope. So get it, Cmake lists txt that we can simply paste the same, exactly, quite same actually, not exactly. And as you see here, we just find package Qt core here. So I changed it a bit. So now we are trying to find the GUI and the widgets. This is just I'm trying to show you another example how you bind if you have any package or something else in the Qt core for network, for example. What you should do? You should find the package simply. These are same, right? This can be gone. No need. Then you will add executable. If you have another CPP file, you can add here for the Qt GUI is the name of the binary. Then you should at the end target the links. Actually link the libraries for target, which is the GUI application Qt GUI. So we are linking core, GUI, and widgets. That is it. So save it. So now let's check the Qt Cmake here. This one, right? If I'm correct, Qt6 yes, this is correct. So now, this is nice. Found xkb, yeah, this is okay. Then Cmake build here. Nice. Then let me find some image. I don't know, voila, PNG v4. Here. I don't know. Okay, this one, for example. I'm just trying to show you. So copy the link, the address of the image here, right? So yeah, I'm just copying here. I cannot access right now. I will send to the Raspberry Pi. Paste here, JPEG. Okay, I'm just changing the name. Move for whatever to test JPEG, right? JPEG. So move test JPEG and the Qt GUI, not move SCP Qt GUI test JPEG here, send. Okay, they send it. So let's switch to the Raspberry Pi now. Here we should see the GUI here, right? Qt GUI, the application that's just compiled, and the test JPEG. Let me try to run Qt GUI. Voila! Yeah, it's working. Nice. That is it for this tutorial then. So what we learned here, let me summary how we can compile the Qt6 with the Cmake for the target, right? We created it in the beginning. First, we make it ready the target. We just install some development packages. Then we create an Ubuntu virtual machine, right? Be careful about the versions, of course, the operating system in the Raspberry Pi and operating system for the host, the Ubuntu. Then we make it ready, install some packages. Then we install the toolchain. We create directories, Then we install also the Cmake in the beginning because of the problems I saw before. The current version for the Ubuntu 22 is not working as I tested it, but you can test it if you want. So then, what we did, I forget it. Yeah, then we compiled we get toolchain, right? But before it, we built the Qt6 host, right? For the host, as I told you, Qt6. If you want to compile the Qt6 crossly, you need a build in the host, right? Also the host version and the cross version should match. Otherwise, you can see problems you can have it. Because the packages are different, right? This is normal. So be careful about it. And just on the versions, you can compile, you can configure it differently. This is the weird thing. Maybe I'm wrong. I didn't try this. Exactly, because the configuration for the Qt host is different than now the cross with us, but the Qt cross is working, right? The cross compiled version is working. And what we will do then, we compile, we make the cross compilation, right? Giving the correct paths for the directories. At the end, we will not see any, we didn't see any problem. This is nice. You can see some dependency problems. This is not normal. If you change the version of the Qt or something else, but you can give the comment and let's check. But if you use the exactly same thing, same for everything here, the versions, the host Ubuntu version, Qt for the Qt6.3 and the operating system and the Raspberry Pi, then you shouldn't see any problem. Exactly like here. So that is it. Thanks. Then in the next tutorial, I will show you how you can compile the modules, right? I showed you the submodules, right? As I told you, I didn't want to compile all the Qt as a single because it will take more time. So I don't want also the other modules that I don't need. I don't want to compile them. Then I will show you in the next how you can compile these modules. These are more easy, more because the base one, the hard ones, all right? So the others are quite easy. So that is it.